All right, Assalamualaikum and very good afternoon to all students. All right, today I will giving you a briefing about experiment number 5, okay, which is a TLC, which means a thin layer chromatographies, okay. So this experiment focusing on the lipid chapter, okay. So chapter number 6, right, on your MIC 180. Okay, we start now. So please be ready with your manual, okay. So now we go to laboratory number 5. It's a thin layer chromatography, or in short form, we call it TLC. Okay, so this thin layer chromatography is focusing on the lipid products. Okay, that's why we have a standard such as olive oil, olic acid, cholesterol, and phosphatidylcholine. So these standards come from lipid products or fats. All right, to start, we have to prepare our samples. So mostly samples we done is a groundnut extracts. Okay, so we add about 4 ml of methanol and 8 ml of chloroform. Okay, 4 to 8, and then plus 5 milligram of groundnuts. Okay, we have to mix well. Okay, 3 items here, and then we have to done the centrifuge work for at 3000 RPM. Okay, rotation per minute for 5 minutes. Okay, and then after that we'll get the what we call sample. We get the top layer and the bottom layer. Okay, so we take a top layer there, and then we filter. That will be our samples in our experiment today. Okay, so that's how we call several standard that we use, such as olive oil. Okay, olic acid, cholesterol, and phosphatidylcholine. So this spot type standard is come from fats or lipids. Okay. So first of all, the methods that we're going to do is number 1, we have to pour the solvent into the chromatography tanks. So they are what we call tanks to put your sample inside. Okay, this tank and seal it. Okay, so these chromatography tanks have what we call several solution, which is a methanol and chloroform. So we have to mix these two, and then we put it inside the chromatography tank. So why we have to seal it? Because we put it a volatile solution, such as chloroform and methanol. Okay. So the atmosphere is saturated with solvent vapors. So what is solvent vapors? Solvent vapor is come from chloroform and methanol. So these two types of chemical is very volatile. Okay. So this one is done by our lab staff. Okay, bukan awak buat. Okay, masa kita buat eksperimen, lab staff akan mulakan proses tu. And then what you have to do, first we have to apply a drops of mixture to be separated onto the sheets of the thin layer chromatography, or TLC. This is the origins of chromatogram. So, bila kita buat kerja tu, dia akan bagi awak satu plate atau kaca ataupun kertas. So that we call it chromatogram. Okay, and then the spot should be small and concentrated. You have to put the spot inside the chromatogram tu. Okay. And then repeat for the sample. Sample kita punya tadi adalah kita punya groundnut tadi, right? So put about 2 to 6 spot or 2 or 6 dots. Okay, dalam eksperimen lain dia akan tulis dots. And then standard. So standard, what standard? Standard kita ada 4 tadi. Olive, olic acid, cholesterol, and phosphatidylcholines. Okay. So make sure you label spots with ABC 1 to 3. Okay. And then place the chromatography sheets yang dah awak buat tadi into the tank. What tank? Chromatography tank contain the volatile vapors or solvent, which is methanol and chloroform. Okay. When the solvent has nearly reached the tops of the TLC is removed, and the positions of the solvent front will be marked likely using pencils. Okay. So the chromatogram need to be developed to make the spots visible by using the specific what we call reagent. Okay. The chromatogram can be analyzed by measuring the distance traveled by the solvent front and distance from the origin to the center of each spots. So we have to calculate RF value ataupun relative fronts value for each of the spots. So how we get the RF value? First of all, you have to put the distance moved of the spot, which is represent a sample, okay, divided with the distance movement by the solvent, which is the solvent front. So mostly solvent front tu adalah pergerakan kita punya cair tadi, campuran metanol dengan kloroform tadi. Okay. And then RF value can be used to identify component of the mixture by comparing to the standard RF value. Okay, so each of the spot standard tu kita akan dapat nilai RF value. So nilai RF value tu kita kena samakan dengan kita punya samples. Ataupun kita boleh tu unknown samples. Okay, so nilai RF value yang mana paling dekat sekali dengan RF value unknown sample tadi yang kita prepare sebelum tu dengan standard ataupun control, kita akan katakan bahawa bahan di dalam unknown sample tersebut refer to the 4 types of standard. Standard apa? Adakah dia olive oil? Adakah dia oleic acid? Adakah dia kolesterol ataupun phosphatidylcholine? So this one is very simple experiment, okay. Dia kata awak ada sample fat, tapi awak tak tahu apa kandungan dalam dia, tapi awak ada standard. So standard tu kita boleh check. Sama ada fat tu banyak pada apa? Is it olive oil, oleic acid, cholesterol or phosphatidylcholines? Okay. That's the process of experiment all about. Okay. Right, is there any question before we go for the summary of the experiment today? Ada soalan tak sebelum saya sambung ke arah the principle of this experiment today?
No, sir. No, sir.
Alright, kalau tak ada soalan, kita akan sambung dengan principle of experiment today. So this note pun ada dalam awak punya feature. So kita akan tengok nanti. Alright, TLC chromatography continue. So this one is a note. So note is available in your course content under our lab today, TLC. Right? Okay, TLC. What is TLC? TLC technique used to separate non-volatile mixture. Okay, something that will not volatile mixture can be used this technique. Okay, so TLC perform or TLC contain of what? Number one, we have what we call sheet of glass, plastic, or aluminum foil. Okay, so this TLC can be performed in any of sheet of the glass, for example. Number two, example two adalah plastik or in aluminum foil. So ada 3 jenis TLC yang kita boleh gunakan, sheets of glass, plastic, or aluminum foil. Okay, but in each of it, you have what we call coated. What is coated? Coated is a thin layer of absorbent materials on each of the glasses, plastics, or aluminum foil. Okay, so what is absorbent material yang ada dalam situ adalah silica gel, aluminium oxide or alumina, or cellulose. Okay, so this layer of absorbent which is contain apa dia? Absorbent tu ada apa dia? Silica gels, aluminium oxide, and cellulose is known as the stationary phase. So apa yang ada dekat dalam tu dipanggil sebagai stationary phase. Okay. So apa itu stationary phase? Polarities Okay. So dia ada bahan yang tersembunyi dalam kita punya absorbent tu. Okay, bahan-bahan tersebut bergantung kepada increasing of the polarity. So what's polarity? Polarity is something that can be attached with the samples or molecules. Okay, so from here, kalau tengok daripada gambar ni, nota ni, there are a lots of what we call polarities materials. Okay, from low. This is one is low. For example, siloxane ni adalah polydimethyl siloxane. Is one of the very low. So maknanya kalau ada bahan yang melekat pada polydimethyl siloxane ni, dia akan berada kat bawah awak punya kertas tu ataupun sheet tu. Tapi kalau paling ringan adalah activated carbon. Okay. So dia we call kita ada polydimethyl cellulose, methyl phenyl cellulose, cyanopropyl okay, carbowax, polyethylene glycol, reverse phase or hydrocarbon coated silica, for example C18, okay, paper, cellulose, starch, calcium sulfate, silica, chlorophyll or magnesium silicate, magnesium oxide, alumina, or mostly using aluminum oxide or acidic, basic, and neutral can be detected in here. And activated carbon, what we call charcoal or noric pellets. Okay, so kalau kita nak buat stationary phase for chromatography, most of all kita akan mixkan semua bahan-bahan ni. Alright, so today experiment we using what we call paper, cellulose, and silica and alumina. So mostly untuk sheet for TLC or stationary phase, kita campurkan dekat bahan yang adsorbent tu adalah alumina, silika ataupun cellulose. So paper pun boleh guna, tapi paper kebanyakannya tak banyak benda yang kita boleh dapat detect kecuali awak campurkan paper tu dengan alumina. Okay, so awak coated dengan alumina. Why? Because alumina have what we call polarity will increase. Okay, nampak ni, alumina akan increase bila melekat pada bahan tersebut. Right? After the sample has been applied on a plate, a solvent or solvent mixture known as the mobile phase. So kita dah ada kita punya sheets. So sheets tu ada adsorbent material. So adsorbent material tu dikenali sebagai stationary phase. So bahan yang kita dropkan ke dalam kita punya stationary phase tu dikenali sebagai solvent. So that solvent we call it as a mobile phase. Bahan yang kita letak dalam kita punya sheet tu. So it is drawn up by the place via capillary actions. Akan bergerak secara capillary works ataupun capillary movements. So why we get a separate analysis? Because of the different rates, okay, and different types of analytes. Okay, so the mobile phase has different property from the stationary phase. Kenapa dia ada different properties? Because of the standard stationary phase yang kita dapat ni. So macam contohnya macam starch bersifat apa? Pada punya sampel. Okay, ataupun kita ada alumina. So alumina bersifat apa? So bahan-bahan yang ada acidic, basic, and neutral saja akan melekat dan naik ke atas volatile, right? So elution sequence by the functional groups. Okay, elution adalah bahan yang kita gunakan dalam silika or alumina TLC or column chromatographies. Okay, so we have depend on the increasing functional groups of polarity. So that's meaning of functional group, Okay, functional group paling rendah ataupun lowest or slowest sulfonic acids. Okay, yang paling berat adalah alkene hydrocarbon. Of course, hydrocarbon memang paling berat sekali. So bila kita buat eksperimen, bahan tersebut akan berada di bawah kita punya kertas. Right? Second will be alkene halidase or halocarbon, alkene olefins, dienes, aromatic hydrocarbons, aromatic halidase, esters, ketone, aldehyde, amines, alcohol, phenols, carboxylic acid, and last one will be sulfuric acids. So one increasing functional group polarity bergantung. So kalau tengok hero ni, okay, so the highest to the lowest. Okay, so what's meaning of highest and fastest? Elute with the non-polar mobile phase. Lowest and slowest need the polar mobile phase to elutes. Okay, all right, that's all for notes today. Is there any question before I'm showing you the video about the process of experiment today? Ada soalan tak sebelum saya tunjukkan video mengenai TLC? So how you do the TLC works? Ada soalan?
Tak ada, sir.
Alright, so saya akan tunjukkan video.
Tak ada.
Okay, saya akan tunjukkan video. So boleh tengok video tu.